Can you explain the difference between the charged ascorbate molecule and the uncharged dehydroascorbate molecule in the body? Do different cells and organs prefer one form over another?
A very interesting technical question. So there's three forms: the fully buffered, fully reduced ascorbate with the minerals as the counter ion. Then, if you lose the electron from ascorbate, you form DHA, dehydroascorbate. And if you lose another electron, instead of having a reversible process, so you can go back and forth between ascorbate and dehydroascorbate with the benefit of selenomethionine and tocopherols, with the benefit of glutathione and taurine and FAD and NAD and many of the intermediary metabolites. So ascorbate is the form to take orally and parenterally, although there are times when certain cells in the body allow the ascorbate to donate an electron, forming DHA, which is taken up into the cell easily, and then converted back into ascorbate in a recycling system with ascorbate as the central player. So every other antioxidant, whether it's in the membrane, the cytoplasm, or even in the mitochondria, depends upon an electrochemical state that ascorbate sets, and only ascorbate in biology is powerful enough as an antioxidant to do that. So most people have a high redox. Most people lack ascorbate. They also lack dehydroascorbate because they're in an oxidative state, and the ascorbate loses an electron to become DHA dehydroascorbate. Dehydroascorbate loses a second electron, and now it can't get back. It forms diketogulonic acid, which the body wants to excrete because that's a acidic metabolic waste product. So if you read the literature, and particularly I'd recommend Professor Beutner's review articles. They're technical, but they're readable. And he points out that ascorbate is the central repair and healthful healing molecule in biology. I will make a point here. Many people say that glutathione is as or more important than ascorbate. That's not quite true. We need glutathione. But Alton Meister, many years ago, showed and reached consensus in the scientific world that the best way to raise glutathione, the best way to preserve and recycle glutathione, the best way to get the benefit of glutathione is to have enough ascorbate. And it turns out glutathione is not taken up from the intestines. We take up the amino acids and the cells make the glutathione. Glutathione is not taken up from the blood. Cells take up the amino acids, glutamine, cysteine, glycine, and synthesize. Glutathione synthetase is inside every cell. You make glutathione and you use it inside the cell with the help of ascorbate. So ascorbate is essential. Glutathione is important. You want sulfur-rich foods and sources to build glutathione because biology is like a ballet. It's choreographed. If you have all of the components working together, the system is very efficient and protects itself. But if you lack any of the essential performers, any of the essential molecules, now risk goes up exponentially. And if you lack 2 or 3 of the essential molecules, like maybe you're low in selenomethionine and you're also low in sulfur sources in your diet, now risk compounds. It becomes geometric. So the takeaway message is ascorbate sets the electrochemical potential. Healthy people have a low redox and they're protected. People who are unwell, almost universally, have a high electrochemical potential and they're in an oxidative state, which means the ascorbate becomes dehydroascorbate, becomes diketogulonic acid, and is lost. So ascorbate goes back and forth between its reduced, more helpful, more potent self, the ascorbate, and the DHA, the dehydroascorbate, with the help of all of these other antioxidants that need to be regenerated. And what you need is the ascorbate taken orally so that the body can select which form, the fully buffered and reduced form, the ascorbate, or the 1 electron donor reversible form, DHA. So it's a complicated question. I have a whole review article. I sometimes give an hour-long talk just on the subject of ascorbate, dehydroascorbate, and diketogulonic acid. I've tried to provide the basic message and the takeaway. We could spend the rest of an hour, but we won't right now, on all of those details. If any people are technical and want to contact us at PERC Integrative Health, we'll be happy to send you a PowerPoint slide deck with some notes that people have told me clarify the issue. And the conclusion is you take in ascorbate, the body uses ascorbate and dehydroascorbate as a partner back and forth. And if you're in an oxidative state, like too many Americans, you'll form the diketogulonic acid, the double oxidation product, and that must be excreted because it would harm the body if it built up.